Hello, students. Let's understand acceleration in very simple terms. In the previous videos, we have talked about velocity and speed, and both of these are basically when you are changing your position from one place to another, how quickly you are changing. So, can I say that it is the rate of change of my position, how quickly I am changing? Yes. So let's understand this. We are going to understand the term rate of change first, and then we are going to go into acceleration with a very simple and relatable example. So when we say rate of change, I'm going to demonstrate how this works. So let's say that I'm standing here in the initial point. Let's say on t is equals to 0. Now what is this t is equals to 0? T is equals to 0 means that here, or this is the point where I'm starting my stopwatch, right? So on t is equals to 0, I'm standing here. 2 seconds later, I took my time and I reached here, right? I changed my position. What did I do? I changed my position. Or let's say now I'm here again, and this time I hit the stopwatch and I'm here much quicker, right? So the rate of change of my position, like how quickly I went from there to here, is basically what rate of change means. Now generally rate of change is in terms of time, like how quickly. But talking mathematically, rate of change can be in terms of anything. But here we are only going to talk about rate of change in terms of time. If I am doing something quicker, rate of change is higher. If I am doing something slower, rate of change is slower, right? Now, acceleration. It is very confusing for many students that if acceleration is high, whether I am going faster, or if acceleration is slower, whether I am going slower, or what does it mean? We are going to make it all clear for all of you. Okay, so let's understand this with a very simple example. Let's say that I'm going on a highway with the speed of 40 miles per hour, right? Now suddenly, let's say 500 feet away, I see an ice cream truck, and I'm like, okay, I got to have that ice cream right now. So what do? I just keep moving with the same speed? No, I want to reach there quicker, so I increase my speed, don't I? Right? So what do? I was moving with 40 miles per hour speed. I increase it to 50 miles per hour, right? Now I can do this thing in two ways. I can take like 20 seconds to slowly increase my speed from 40 miles per hour to 50 miles per hour. Can't I? Right? But I can do it quicker as well. I took just 5 seconds from going from 40 miles per hour to 50 miles per hour. What did I do? In the first case, I sped up quickly, whereas in the second one, I sped up slowly. In both the cases, I sped up, didn't I? Right? My initial velocity and final velocity were the same in both the cases. So acceleration always means to increase your speed. What do I say if I decrease my speed? It's called deceleration. So when I'm talking about acceleration, whether the acceleration is higher or whether the acceleration is lower, it's always going to increase your speed, right? So when do I say the acceleration is higher? When I increase my speed quicker, rate of change. What is acceleration? Rate of change of velocity, or speed. So if I change my speed or I increase my speed quickly, my acceleration is higher. If I increase my speed slowly, then my acceleration is lower. But in both the cases, your speed is increasing, right? Now there are two types of accelerations. First is average acceleration. What is average acceleration? Let's take the 20-second one example. So I went from 40 miles per hour to 50 miles per hour in 20 seconds. Fair enough, right? Now, is it necessary that I have sped up 0.5 meter per second every second so that I equally distribute my increase of speed in entire 20 seconds? No, not necessary, is it? right? It's not necessary. So I might have sped up a little bit too quickly in first 5 seconds. Then I realized, okay, I'm going too fast. So I slowed down, and in next 10 seconds I sped up a bit slowly, and then in next 5 seconds it was somewhere in between. So in the entire 20-second span, the speeding up process was not uniform. It was not uniform at all, right? But still I sped up 10 kilometers or 10 miles per hour in 20 seconds. So how do I explain this to someone? Do I just tell them again and again and again that in first 5 seconds I did this, and next 10 seconds I did this, and then next 5 seconds I did this? Of course it's going to be too tiny. So what do? I use a term average acceleration in order to explain how I would have distributed this entire process equally or uniformly among the entire time. So what do? Average acceleration is the total change in velocity divided by total time taken. Sir, what is this minus? So this one is here, that change in velocity, final velocity minus initial velocity. But this is basically the time period. So let's say I have been observing from 0 to 20 seconds, this t1 becomes 0. If I am observing from 10 to 30 seconds, the time period still remains 20 seconds, but t2 becomes 30, t1 becomes 10, right? Similarly, now if I am talking about, so this one is for the entire process of acceleration. What if I want to observe my acceleration on 3rd second, on 4th second, on 10th second, on 15th second? I use something called instantaneous acceleration. How does it work? It's very, very simple. So what do is, here I am talking about the entire 20-second period, but in instantaneous I am talking about a very, 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 very small period. So how small? As small as possible, something called dt, that is a very small change in time, right? If the time change is very small, the velocity change is also going to be very small. So small change in velocity upon small change in time. This becomes the differentiation of v. If you want to get acceleration on a particular point, you differentiate the function of velocity with respect to time and then put that particular time in the equation. That's how you get instantaneous acceleration. I hope that was very, very easy to understand the concept of acceleration.